All right, to begin, we're going to start talking first about what a variable is. So a variable is a quantity that typically changes in the context of a problem. So it's some kind of unknown that we need to try to figure out what it is. And what that number does is it is, once you have found it, it's the solution to that equation. And what I mean by a solution, it's that quantity that actually makes the expression or equation true when you plug it back in. So you are all typically used to seeing that, hey, this variable is X or Y, but it could also be a couple other things. It could be symbols, so it could be mu, it could be some kind of alpha or omega or other Greek symbols that typically represent it. So um, you may see theta, stuff like that. So all of these are just some kind of representation of, hey, we don't know what this quantity is and we need to figure it out. So the purpose of this video is to figure out what those variables actually are going to represent, so what the solution to these equations are. So we have some examples we're going to work through. So this video is just going to cover a single step solution. So that means you're only having to do one thing to get what the answer is. So when you're looking at this first problem, we have x plus 2 equals 7. So that x plus 2 equals 7 is going to be our equation. And I'm trying to solve for this x. So this is what I am trying to solve for. I'm trying to solve for that x. What number, if I plug in and I add 2 to it, is going to be 7? So you could think about it that way. What number plus 2 gives me 7? And instantly off the bat, you're probably thinking, hey, 5 plus 2 gives me 7. And the solution for this problem is 5. But there's other ways mathematically, algebraically, that we can actually solve. So we're going to do that solving. So when you are solving for these variables, you want to move or isolate that variable by moving everything to the other side of the equation. And you can move these other quantities by doing the inverse, so the opposite operation that's being done. So you see how we have that x plus 2? So that means we're adding 2. So what I want to do to get rid of that adding 2 is I want to subtract 2. Because when I subtract 2, I'm going to get out 0. So when I do plus 2 minus 2, this outcome gives me 0. So that means I've gotten rid of any number at the beginning. So this x plus 2 is now x plus 0, so this doesn't matter. But to make things balanced in life, what you do to one side of an equation, you have to do to the other. So since I subtracted 2 on one side, I also have to subtract 2 on the other side. So it's kind of like if you had like 3 apples in both hands and you want them to constantly be even. If you drop one apple in your left hand, you have to drop the apple in your right hand to keep making it equal. So what you do to one side, you always have to do to the other. So 7 minus 2 gives me 5, and that was what we were looking for. We got x equals 5. And again, right off the bat, we said, hey, what number plus 2 gives me 7? And that was 5. So let's look at another problem. So we have negative 5 plus x equals 3. So negative 5 plus what number is going to give me 3? So maybe you see this right off the bat, maybe you don't. It's okay. So again, I want to get rid of any number that is being added or subtracted to that x. So you may ask yourself, is negative 5 being added or is negative 5 being subtracted to that x? Well, negative 5 is being added. But so that means we would have to subtract a negative 5. So subtracting a negative 5 is really just adding 5 to both sides. So really all I'm having to do is just change the sign of whatever number I want to get rid of. So this -5 plus 5 is going to go away, and I'm going to have to add it on both sides. So again, -5 plus 5 is 0, so this just cancels. So this leaves me with x equals 3 plus 5 gives me 8. So then I can go back and ask myself, does -5 plus 8 equal 3? And yeah, it does. So that means we did it right. So that is adding and subtracting. So these are both single step problems. So we have other types of single step problems. So here we have 5x equals 45. So looking at this problem, again, I'm trying to isolate. So I'm trying to get this x all by itself. So I need to figure out how can I get x by itself. So in the other problems, the first two, we were adding or subtracting something to that x value. But now I have this 5 and it's being multiplied to x. So I need to get rid of this multiplication. So just like we were doing the opposite operation, what's the opposite operation of multiplication? Well, that's division. If I multiplied something to a number, I can then divide it and I get back to the original spot. So that's what I want to do. I want to divide some number on both sides. So the number I'm going to divide on both sides is going to be 5. And the reason why this works is 5 divided by 5 is equal to 1, and that's 1x. So I got rid of this coefficient, this number that's being multiplied to x, because 1 times anything is still that same number. So that doesn't really matter. So this 45 divided by 5 gives me 9. So, and that probably made sense to you. 5 times what number gives you 45? And you would have said, hey, 5 times 9 is 45. And that's what we just found right there. So what you should always do is plug back in that number into the original equation and make sure it comes out to be true. Does 5 times 9 equal 45? Yes. So we know we did it right. So now we're coming over to this side. So we have x divided by 3 equals 12. So now this time I need to ask myself, okay, I'm still trying to solve for that x, but this time it's being divided by some number. So what's the opposite of division? Well, we just did it in the past one. When we had something multiplied, we divided. So then if we have something divided, we need to multiply. So I need to go and I need to multiply both sides by this 3. Because again, 3 divided by 3 is just 1, so those are just going to cancel. So 12 times 3 is 36. And again, that one may not have been like right off the bat, you're saying, what number divided by 3 is 12? But now when you're looking at this solution that you have, 36 divided by 3 sure is 12. So we know we did it right. So I have 2 problems for you to try. So pause this video and try these 2 problems. All right. So for the first one, you should have had x equals -26. So 33 plus -26, or another way of saying that would have been 33 minus 26 equals 7. And that is a true statement. On the other one, you should have gotten x equals 22. Now it is 100% okay for you to have written 22 equals x. These two things mean the exact same. The only thing that I would suggest though is always put your variable, your solution, on the left side. So you're trying to say x is, because equals, another word for equals is 22. Because 22 is x doesn't really make much sense when you're talking out loud. but it doesn't matter mathematically. 22 equals x is the exact same as x equals 22. If you did not get these 2 U tries, it's okay. We have plenty of practice, so just keep practicing.